Okay, so we did bromination. Our next specific reaction is chlorination. Chlorination, not coronation. That would be for the king or the queen. But chlorination means we're going to add a chlorine. So again, our specific reaction, and this one we'll see, is closely related to bromination. And I'm thinking bromination, so you see I made a mistake there. You see how easy it is. I want you guys to learn to be careful, not careless. So instead of FeBr3 that we used in bromination, we'll use the chlorine analog, FeCl3, iron trichloride, that is ferric chloride, and the product of this reaction the chlorination, the substitution of one of the hydrogens on the ring for chlorine. All right, now how does this occur? Well, by the same token that we saw with bromine, the chlorine interacts with, and I can push the arrows of the chlorine acting as a Lewis base, a lone pair donor, with the iron chloride, a Lewis acid, and again the definition of a Lewis acid is a lone pair acceptor. If you don't recall those, do look them up. So the iron is beginning to build a partial negative charge, and our chlorine out here that's losing electrons is building a partial positive charge. So this then gives us our electrophile. And remember, it's electrophilic aromatic substitution, but in that the benzene acts as the nucleophile. Okay? So we can bring the double bond out, attack the chlorine. Now we will formally break that bond. This produces for us our intermediate. There's the carbocation, and we have the parallel chlorinated anion that we saw before with bromine. So this is lost aromaticity, and so again, as we have seen for the other cases, regaining aromaticity by loss of a proton makes this carbocation relatively acidic. That sigma bond CH electrons swing down to form the double bond, and that gives us back to our product. So that's chlorination, and you should be able to generate that electrophile and push those arrows and understand the accounting system for the electron.